you guys can still hear me and see me. Just restarted the stream. I don't know if it interacts with Discord. Oh, nice. Admin Pac-Man. Thanks for the approval. I appreciate it. Now that we got an approval, we can merge this. Cool, and it's merged. So no PRs. All clean. So now I do a git done here. It's a small script from mine. Just deletes my local branch, pulls in the changes. We can have a look at the git log. We can see, yeah, implement subcommand scaffolding number 4 by Raf. So now have something to work with. So let's have a look at the README again. What do we want to do next? We can do announcements and attestations, or we can do options, which would mean we store and create the public key. Maybe that's worth doing. Announcements and attestations. Let's try to, no, let's do something else. Let's try to actually do some stuff on the DLC side, and let's try to sign events, which will be part of, I think it's like a, probably finish this part, which like we should be able to sign events. Unsure how we're going to test these things, but let me just try to implement it first. So let's look at the spec. Okay. So Oracle event. Let's have a look at our entities over here. Source event. So an event, when we sign for an event, we sign an outcome, and we basically sign this label. So the Oracle event has the NB nonces. So yeah, they use this weird TLV thing. But to be honest, we just need to figure out something else first. We need to do this. So I think this one is relatively important. UDIF coding is not canonical. There's several ways. So we have to apply this normalization thing to the event which we're signing. So the thing, so here in the outcome, you kind of see everything that we need. We have these secret nonces, or this secret nonce, which we commit to through this adapter point, which we publish beforehand. And then when the event happens, I call this a label for now, might rename it. We basically sign this string, and the string has to be canonical. So basically always be the same when you serialize it. And strings are very tricky. There are many different ways to be serialized. So we have to apply this weird fucking normalization thing. And then there's some test vectors I found in some random repo. I don't know what to do with those yet, but we'll see. So we probably create a function on the outcome called let me make this pub create fn sign, which takes self and returns a signature, which will probably just be a signature for now. We'll figure it out. all these types I'm referencing I already imported in the lib. So like a signature here, the full name would be seg p256k1 schnorr and then signature. Seg p256k1 also has ECDSA signatures which are different, but yeah, the signature I'm referencing is a schnorr signature. And yeah, this whole oracle will just be doing schnorr stuff. I'm not interested in implementing ECDSA adapter signatures. Schnorr is just a much more elegant algorithm. So sign, an outcome can be signed, and then it returns a signature. Yeah, I think that's what we want for now. I'm looking for the exact space where it says Oracle address proposal, test vectors, Oracle validation, Oracle announcement, rationale, attestation. Somewhere in here I saw this Oracle events. Somewhere in here it said UTF-8, something, UTF. Here. Serialization and here it is. Serialization and signing of outcome values. Every outcome value should be encoded as a UTF-8 string with NFC normalization before being passed to the signing algorithm. UTF-8 is chosen as being a widely supported and easy to implement encoding format. For numerical outcomes, which we're not implementing right now, I'm just doing, enumerated outcomes. Numerical outcomes are much more complicated. Yeah, so I'm just like, whatever, I don't care about this. Signing should be done using this signing algorithm and using the tag attestation. So now again we use this tagged hash thing. And if we go to the signing algorithm, just remove these. Signing algorithm is this one again. So last time when we signed, we used the Oracle private and public key. And now we're going to use the secret nonce and the adapter point, which is also a private and public key. And instead of the tag DLC Oracle, at least the spec says we should use this tag. So we're just going to do that and see what happens. Which means we need to, let's do the UTF-8 normalization thing first. I was looking into this before. I was asking Claude about this, and it gave me this horrible piece of code. Let's see, Rust Unicode normalization. So there seems to be a crate for this. Unicode, this is described in Unicode standard. So yeah, so this thing here, outcomes should be encoded as a UTF string with NFC normalization before being passed to the signing algorithm. So here it doesn't mention anything about the big size, whereas when we go, where did I get this? I think under messaging. Working with this spec is horrible. So if we go to messaging and then go to fundamental types, we see here that this string is prefixed by this thing. But I think we don't need this. I think we just normalize the label and don't worry about this for now. Yeah, I don't know. Yeah, I don't know what the exact if this pertains to this outcome string or not. So it's unclear from the spec. So what I will do is just use this nice library. So let's add it. We'll add Unicode normalization. Awesome. Have fun, Packbot. The video might have been interrupted and then there's a new video because I had to restart the stream. So yeah, there might be 2 videos up. I don't know, like my OBS setup sucks. I'm always doing something wrong, but yeah, have fun and good flight. Unicode normalization. I think I'm just gonna port this in here because I'm literally only using this here. And if we use it somewhere else, I'll think about that. So Unicode normalization, and then we want 2 things here. We probably want char compose. We'll see. We'll see what we need. And then we do Unicode normalization, which is just an interface. We'll see if this works. So when we sign, we let normalized label equals self.label .nf. So this is pretty cool. So what we did right here is we imported this interface or this trait, and this trait implements then this normalization thing for any string. So we can just call this string NFC, and then it should. I don't know about the UTF-8 thing, but like yeah, and then it should normalize it. So we do this dot collect, and then we create a tagged hash, and then now this tagged hash of course takes different tag. So we go to lib. So we have these 2 tags. I'm just going to call this the Oracle tag, and then this I'm going to call the attestation tag. And this one is going to be whatever they say they want it to be, which is this weird thing. Yeah, I have no idea if any of this works, but I'm going to try to follow the spec as well as I can. And now this tagged message hash, we need to now pass in a tag, which is going to be a string. And then we're going to just put in the tag here. And then everywhere we call this, oops, we're going to have to, so I'm just going to be lazy. So tagged hash, so this is a pub key, so over here we're going to use the Oracle tag. And Then over here, this is also going to be the Oracle tag. And yeah, so this is complaining, that's fine. And then we do let tagged hash equals tagged. I can't fucking type right now. What the fuck's going on? The message is gonna be the normalized label as bytes probably. Have to check the UTF-8 thing, and then the tag is gonna be the attestation tag probably. And this is a string, and it should be fine like this probably. And then we actually need to assign it. Turbofish. Collect this as a string again. I have no idea if this works. We'll see. And I also need to test. Yeah, I need to test it against the test vectors to see if I'm doing this right. So now we need a set p. Now I need to do some cryptographic operations. I think I can just inline this. And then it's going to be sign schnorr. There's no external randomness, and it's going to take a message, which is the tagged hash. And it's going to take a key pair. Does it always need a key pair? I guess. So this is interesting now. I don't know if it's as simple as just signing this. This might be where I use the adapter signature, because I need to commit. I need to sign with this adapted point as my nonce. So yeah, let's look at the spec. So you can see what the hell I'm doing. To look at the actual paper. So this is the original paper. Oops. Okay. Committed R point signature. But then on your normal users create a private scalar A. Contract creation, transactions, Oracle signing. So yeah, the Oracle sets M to be the observed price. This example, yen percentage dog computes this thing. So, oh, interesting. What was the K again? When sending messages that create a random private scalar K, compute R. kg. Can be made up of different keys held by different parties that will publish another point. Here's a random nonce. So K here is the secret nonce, and R is the one-time use signing key. In this case, R is the adapter point. This is the same K and R used in normal, but the R value is committed in advance of the signature being calculated. The message to be signed is not yet known. Yep. So I think I need to actually sign okay. So this 1500 that is displayed here is the tagged hash, I think. But then I need to hash it again with the R value and then multiply it by my normal public key and then subtract it from the secret nonce. Okay, so there's actually the gist of it. Rust CKP. So there's this SecP SecP advancement or improvement or whatever you want to call it. Adapter. For some reason they only have fucking ECDSA adapter signatures. That is very unlucky for us. But there's also this Schnorr fun. Schnorr signatures introduced by the namesake Schnorr fun. Cool. So we have a module here called adapter. Algorithms for Schnorr adapter signature encryption. Expect this means you can't get the signature from the encrypted signature unless you know the encryption key. Signing key pair, verification key, decryption key, encryption key, message, text Bitcoin. So it looks like this message thing, this looks like a tagged hash, to be honest. Interesting, okay. Let's know the signing key pair, encryption key, encrypted signature. Let's see, adapter. Okay. Let's look at the spec again, so we're doing things right. Do I just basically sign this? Is this just what I have to do? I don't know. I just sign that number with the pre-committed nonce. PPUB is fully known. I mean, let's just see what happens if I do this. I mean, this is probably wrong, but we can figure this out. Thick P. I'm figuring these out as I go. Okay, and then the secret nonce is self.secret nonce, and this one takes sig P, and then we sign it. Key pair, and then this returns signature. Oracle tag. Let's see what this chart compose does. What is that for? Let's see what this one said. Normalized string, normalized bytes, get length, encode big size. Yeah, I'll extend that. And this is UTF-8. Due to unexpected capacity restraints. Okay, fuck that. Let's do a result signature. I guess I don't need this. Now I actually have to use this sign thing. Okay. I'm concerned about here, like I'm just signing this event with these secret nodes and adapter point, but here in the DLC paper, they add the V, which is our Oracle private key. So, yeah, unsure about this. Okay. Let's actually use this function somewhere so this stops complaining. Events. Let's do assert. Let's do event dot outcomes dot first dot unwrap dot sign dot serialize dot length. We want to make sure this is a proper signature. Sign dot unwrap. These are tests, so I can do unwraps in here. byte array. Okay. Now we have to use it somewhere, so sub command run. Let's just Oracle events. Let's just do a print line so it doesn't complain. So this returns an event. So then we just do event dot outcomes dot first, whatever the first outcome is. We do sign to byte array. Maybe we don't need a byte array. I'm just gonna call this signature for, or I mean, yeah, signature for event and outcome. So we do event dot name, event dot ID, and event outcome. Outcome dot label. Okay. Cool. So let's run this, see what happens. Okay, signature. Let's add a line here. This is so dirty. Run. Signature for event even or odd and outcome even. And then we have a signature. Interesting. But the test, no, a signature is not 32 bytes. A public key is 2 bytes. A signature is 64 bytes, sometimes 65. So, where do we have this test? This should be 64. JCI. Oh. And if I make this 65, and it fails. Cool. Yeah, it's 64. Our signature is 64 bytes. But this is probably the wrong signature. Gonna be honest. GCP sign outcomes. Sign outcomes. HPR create. Okay, Eon games, have fun. Oh, that was 5 minutes ago. Oops. Sign event outcomes. I'm going to do some Claude research. You figure out. Yeah, it's different. ED is different. Code uses standard source signing. Use the committed R point. Yeah. Yep. Yep. So I think what I'm going to do now is going to look at another implementation of an Oracle, because I'm not sure about what I'm doing. Okay. Price feeds, Oracle. Let's look at source Oracle mod, and then source Oracle scheduler mod. Should be some stuff in here. Let's see how they do it. So they create a new Oracle with these things. Whatever. Oracle public key. Oh, nice. So yeah, they also use the same structure here as me. Event data. And the scheduler is probably what's clockwork. What's this? A simple scheduler. Okay, cool. Scheduler. Cool. Damn, they have some unsafe code in here. Shine schnorr with knots. Ah, yeah, this is what I need. Oof. SecP sys, SecP schnorr sign custom. Yeah, that's what I thought. Need this custom thing. Build attestation. Outcome, a message, match signing version, basic. SHA and DLC v0 attestation hash. Probably DLCV outcome tag hash. Yeah, look at this. So, damn, okay. Okay, interesting. So this is the actual thing, so the fucking spec is wrong. Oh, he's good. Yeah, the spec is, the repo hasn't been fucking updated in 2 years. Yeah. That's, so, which makes sense. So this is just the Oracle tag. And then the attestation tag is actually also this thing. And then we will also have a announcement tag. I guess there's also an announcement tag. Announcement mid-state. Oof. These probably also have to be normalized. For now. Oof, okay. Announcement. Is that correct? Wait, type it. Announcement tag. I'm not gonna use it for now. Okay, so they use this. They use this thing, and then they probably write it out to make sure that's correct. Put the actual bytes in there. But what's weird is that DLC both start with DLC, but have different hexa. Maybe it's encoded. And why is it always exactly 32 bytes? What the hell is this? Mid state. This should be the length. Interesting. What is this? Is just a message? What's this message thing? So they use ECDSA. Interesting. Signing version. Signatures is a bank of signatures. Outcomes, sure. And then sign schnorr with nonce. Yeah, that's what I need. Sign schnorr with nonce. What the hell are they doing here? Huh. Interesting. 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 Schnorr signature size is always 64. Yeah. Nonce params. Sec p Schnorr 6 sign custom. Let's have a look at this. Rust sec p. Schnorr sign. Schnorr 6 sign custom. Schnorr 6. Huh. Sign custom. Scalar random custom. Okay. What is sys? Huh. Okay. Let's go to the docs. Sign custom. Sec p Schnorr sign custom. Oh man, it's a fucking C function. Oh man. Oh man. Oh man, oh man. We could just copy this. Yeah, I have to sign this weird thing in exactly the way. Which one is it? No, it's fucking this thing. Let's see if they actually do that. And look at the source. Look at some C code. Schnorr 6 sign extra params. Schnorr nonce function. Create a new Schnorr sign params properly initialize. Pointed to a nonce generation function. If null v nonce function is used, n data pointed to arbitrary data used by the nonce generation function. Okay. Okay. Okay, let's just copy this. I'm just gonna put it into the lib somewhere over here. I've never used extern C. Hot damn. So I also now need sign. New. And it seems like I need the message. And it seems I need a key pair, but this is now spelled differently in the newest version. Cargo add sec p sys. Non-sec p2x6 fuzz. Okay. Let's see. Cargo tunnel sec p sys. We do version features. Okay, cool. Change nor with nonce. This is okay. This is fun. Let's go over here and how do they generate the message? So they do message from hash data. What is this? Interesting. And then you create this specific hash type. And then they have this hash type. Maybe I can be. So the message, what is this? It's a message. Oh man. Normalized label tagged hash. So it takes a sec ps. Let's just see if this works. I have all in here. I could just initialize the signing context. It takes a message. I think I implemented this somewhere before. Projects, bit2 source sign message. Yeah, from digest slice. That message. So we have a message, we have a key pair, and then we have a nonce. So then we do self.secret nonce. And returns a Schnorr signature, which who knows what the hell that is. Let's see what they use as the Schnorr signature. Represents a Schnorr signature. Okay, that should be fine. So we're going to just return a signature, and then so the sig. So this is what we're going to write it into, and then we're going to just do see what happens. Feature flags. Okay. Interesting. It doesn't seem to have these features. Our signature size, I'm just gonna be, it's just 64. SigP context. Core. What the hell is a core? Okay, core exists. C pointer, key pair, C pointer. Okay. Method length found reference. No method named length. Type non-null cannot be the reference. Mm-hmm. Message dot length. So the message is this thing. Message size. So the message is always 32 bytes from slice, from digest. I mean, okay. I could do message 0. It's not cheating. It's a private field. Okay. I mean, I could just do 32. This feels very wrong. Take a context. How do I get the context? Non-null. The hell is this? Huh, okay, so this returns something else. How do I get the non-null context? How do I get the inner type? Where was I? Oracle slash event. No, outcome. Try some more. So now, let's fix this thing. Cannot be dereferenced. Can I call this? Or sign custom. This is tricky. Let's ask ChatGPT. As pointer. Okay. Yeah. Go. Let's fucking go. Let's see if something breaks. Okay. Let's commit this. We're somewhere. Sign outcomes, git commit sign outcomes with custom schnorsig. Ah, fucking hell. Git push. Do I already have this? Do I already have? Okay. This beautiful piece of code. Wow. Wow, okay. But I think this is the core of the Oracle, signing these outcomes. But we really need to test this, so... Yeah, I need to figure out a way to test this. And then everything else of the core Oracle is just... you know, just like building stuff around, but the core of the Oracle is signing these messages. And I'm unsure about many things. I'm unsure about the tagged message hash that I'm creating. I'm unsure about this whole thing over here. Yeah. It's complicated. But I think for now, I'm gonna leave it at that, because I have a meeting in a couple minutes. So yeah, I'm just gonna, everything kind of runs, nothing really fails. We do call these functions, so nothing crashes, which is good to know. So yeah, we sign these things, and then we actually test. Yeah, I actually test these. I have a test over here. Test this. Let's run this. there we have the signature. 9-5. Interesting. Okay. So yeah, I'm gonna leave it at that for today. And then continue here next time. Let's see. So yeah, we didn't really do anything over here. So yeah, thanks for watching, guys. I'll try to you know, continue work on this, maybe make this a regular stream, who knows. Don't even know if there's still anyone watching. If you're watching, say hi.